we have second configuration called node port. So whatever problem that we are facing here, we have resolved first problem. That is, even if you lose any one pod, new pod will get created that will be connected automatically. But the problem here is you can't use virtual IP or cluster IP to access from outside the world. Outside means out of the machine. So to resolve that issue, we are going to use node port. Okay. So let's discuss node port now. Now what actually happens in node port? When you create node port, backend cluster IP or virtual IP will be created. But for us, this is unnecessary as of now. We need to focus on only node port. So here what actually happens? Still service port is same. Kubernetes allows you to choose any one service port. And Kubernetes, instead of giving virtual IP, this time Kubernetes is going to provide one node port. Node port. You can't choose what node port that you want. No, Kubernetes will give one node port. That port ranging from 30,000 to 32,767. Remember, these are range. Kubernetes will give one port ranging from this one. Between this range only, it will give any one port. Okay. It chooses any one port from this range only. That's the default behavior. That means between these two, you will get any one port. I'm repeating. You can choose service port, whatever that you want. Node port will be given by Kubernetes. And these two will be mapped. You can see. These two will be mapped here. So whatever port Kubernetes gives, you need to open that port. When you open that port, what actually happens? You know, right? Node is having one IP address. This base EC2 machine, it has both public and private IP. You have to use that IP address, colon, this node port. Understanding, right? In order to access application, you have to use base machine's IP address, colon, this particular node port, whatever Kubernetes gives. Let me repeat, let me keep it in a simple way. Here, Kubernetes allows you to choose a service port, and Kubernetes will give one node port between any one port from this range. That port you have to open in your EC2 instance. And how to access the application? Your machine has a public IP. By using that public IP, colon, this node port. Then the request will go from here, from node port, from service port here. If you try to access again, from node port, service port, second time here. One time here, second time here. One time here, second time here. That means you can access this website from browser directly. Got it? Okay, let's do it now. So here everything remains same. The deployment file, service file remaining same. Only thing is that in place of cluster IP, we have to give node port. That's the only difference. Okay. We are not doing any changes in the deployment file. Cat deploy HTTPD. Here we are not doing any changes. This is same as it is. So changes we are going to do in service file. So in service file, instead of cluster IP, we have to use node port. Here you can see node port, N and P capital. Okay, node port. That's it. Let's apply. No. kubectl apply. Yeah, first let's apply deploy HTTPD. Done. Again, apply service file as well. That's it. Now, kubectl get all. Observe carefully. Deployment object got created. It created replica set object. It created pod object. Fine. Now, the service object we have created, but what is the configuration of that service? Node port. Node port. Remember that. I mean, these are default services that will be there by default. You just ignore this one. So these are service we have created. It created node port. And node port, when you create node port, it creates cluster IP. But this time we don't need cluster IP, so you can ignore this one. I told you, right? Node port will be given by Kubernetes. It selects one random port from this range, 30,000 to 32,767. You can see 31,940. This is what node port. And that is between this range only, correct or not? That is so. It picks any one port from that range only. This is your service port. What do you have selected? This is node port. Both are mapped. You can see node port and service port. Both are mapped. That's it. Over. Now what you do? Open that particular port in your base machine. 31940. Remember, this port we have to open in our base machine. So how to open? Go to security groups. Go to security. Yeah, select your instance. Go to security. And go to security group. Open in a new tab. Edit inbound rules. Here actually we don't need to open that port because you remember, right? Initially when we launched this Kubernetes instance, that time we have opened all ports. Let's say you did not open all ports. You have opened only SSH, HTTP, and one more port I had given, right? That agent, kubelet agent runs on particular port. You have opened only those three ports. Fine. Now if you want to open this node port, you need to add a rule. Add a rule here. Here you don't need to choose anything. You have to enter this port manually. 31940. 31940. Make it anywhere IPv4. That is so. The way we opened Jenkins port 8080, in the same way you have to open this particular port and save. But actually here you don't have to do that because already we have opened all ports here. 0265535. All ports already we have opened. Fine. Now how to access this application? You take base machines public IP : node port. That's it. You can able to see HTTPD. Go to instances. Select your instance. Take public IP. See, this is public IP now. From browser, you can use only public IP, right? Public IP : what is the port? You have to give node port, otherwise things will not work. This is the node port. Paste. Enter. That's it. It works. Even you can try from your side as well. Okay. You open your laptops and mobiles. You can type this IP address. You should able to see it works. Understanding, right? Let me try in my mobile. It should work. You also please try, guys. Open your browsers and type that IP 43.205.215.150 : 31940. Enter. For me, it is working. What about you? You can see. That is how things work. Now, what is the problem here? Here, what issue that we are resolving? The issue that we are resolving is we can able to access from outside, from the browser. Okay, outside the world. Outside the world means what? Out of this node. But what problem that we are facing here? This IP related to this particular node. As of now, we have only one node. That's why we don't have any issue. But later on, we are going to use multi-node cluster. Right now, we are using Minikube. But later on, as you know that, we are going to have master and worker setup. This is Kubernetes master. These are workers, or you can call nodes. Now, that time, what we do, we create manifest, that service manifest and deploy manifest, we apply. When you apply, actual pods and containers will be created here. See pod, let's having 2 containers. Here also pod having 2 containers. Here also pod having 2 containers. So if you want to access the application running here, we have to use this machine's IP. That's what we have seen. Correct? This machine's IP. But that time we have multiple machines. What if I lose my machine? What if you lose your machine itself? Right? Then things will not work again. When you lose your machine, you will get new machine you are going to launch. New machine will have new public IP. Correct or not? New machine will have new public IP. That means public IP will be changed every now and then. Again, customers cannot remember this public IP. Correct or not? So to resolve this issue, we are going to use our third service configuration. That is what load balancer. Load balancer. That's what here I have written, right? What is the third configuration type? Load balancer. So what actually happens in load balancer? Load balancer will get created automatically. Already earlier, we have seen load balancer in AWS. So load balancer will get created automatically. This will get connected to nodes IP address, public IPs automatically. Multiple nodes, public IPs. And internally that public IP will be connected to node port, that in turn connected to service port, that is connected to containers port. This is what service port. This is what node port. Okay. So this is how things work. Colon IP, that IP will be connected to load balancer. This is what actually happens in all these machines. Okay, that means here this IP will be connected to load balancer. Now let's say if I lose any one machine, Kubernetes will launch a new machine automatically. That's what we are going to see. EKS cluster, Elastic Kubernetes service. It creates new machine automatically. The new machine's public IP will be connected to load balancer automatically. That means you don't have to remember IP address as well. Backend, you don't have to worry whether machine is getting terminated, new machine is getting created. That is unnecessary for us. Front end, load balancer will have one static DNS name. As you know, IP address or DNS kind of both are same, right? You can use anyone. So it is for load balancer, we are getting DNS name. That one we use. I hope you understood. Later on, going forward in our projects, see, we can't even remember load balancer DNS name. That is not user friendly. So that's why this load balancer DNS name, we are going to connect to route 53. In AWS, we have service called route 53, where we purchase domain names like www.sai.com, google.com, facebook.com. We purchase one domain name. That domain name we connect to load balancer domain name. That domain name we give to customers. So when customers use www.sai.com, their request will come from these customer. The request will come to route 53 from here, load balancer from here, this IP address to this port, node port through service port to these containers. Like that. One request here, one request here, one request here. So that even if you lose, pod or container, deployment object will create new pod. No problem. Even if you lose your machine, Kubernetes will create new machine. So no problem at all. Correct or not? That means your website will be always up and running, no matter what. Always. That is what these Amazon, Facebook, Google, that is how they are managing. Okay. That's why you will never find these websites are going down because of this reason. Their websites also may go down, their pods also may go down. But no problem, because when you lose a pod, deployment is creating new pod. When you lose a machine, EKS is creating new machine immediately. So customer will not come to know that what is happening at backend. That is how they are making sure that high availability is always there. Always they are making sure that their website is always up and running. But in order to show this load balancer, we need to have multi-node setup. You can't have single node. That's why this we are not discussing right now. Later on, we are going to have multi-node setup. There I am going to show you this load balancer setup. And you don't even have to create load balancer. No, these also will be created automatically. Everything we are going to automate. No manual intervention at all. Understood? Fine. So that's it, guys, for today. Let me show you how to delete as well. kubectl, you can delete this service. kubectl delete. And delete deployment as well. That's it. Now clean. We don't have anything running. Verify kubectl. Get all. Nothing. Understood? Yeah, that's it for now. We'll meet in next class. In next class, we are going to discuss other concepts. Okay.